Welcome back. Nice morning stream here. Shop is still bright. And in fact, we've already got a beautiful cat positioned just right for this stream. Look at that. He's doing such a good job. My lens is not quite in focus. That might be better. Oh, he's so funny. Tico, as always, is super cuddly when he's up here on the rack. So yeah, this is a bit of a different time of day. I've ended up streaming pretty late usually because I end up spending most of the day just getting the equipment ready, and then by the time I'm actually ready to stream, it's kind of late, but that hasn't actually been my intention, so I'm hoping to get some streams out at different times of the day so that maybe people in different time zones or with different work schedules can participate. But I'm also interested in feedback about what times of day work for you. There's the cat hanging out on top of the equipment rack. I've got my tea. And we're back here. So last night we actually got to a pretty interesting milestone on this project. So just for a really brief view, this is the gimbal that, let's see if I can get that on the... Tuco, are you coming down here to join us? He's down here by my feet now. Are you gonna sit up here on this chair, or do you just want to play? So we've got this gimbal, which is going to be part of the robot that follows around my cat and interacts with him during the streams and around the streams and just kind of whenever on the internet for Tuco Flyer. So yeah. Dr. Toon says, I was going to suggest fixing the power dissipation in your audio unit, but it has its uses. Yeah, I assume that it's putting most of that power into the microphone preamps. I mean, I didn't design this. This is just a M audio unit. And I think other people have said that this thing runs pretty hot too, but yeah, I mean, it's kind of tempting to take it apart and debug it, but it doesn't appear to be broken as far as I can tell. The whole thing is pretty power hungry. So anyway, we're in this project trying to control this gimbal and adapt it for use with my cat camera robot. So we've already done these mechanical modifications to fit the camera we want to use. This one has high-def SDI video out that we can run over a little coax cable really easily. And then we also have this LiDAR distance sensor, which we can use to help the robot stabilize and focus. Oh, nice. Piotr in chat says that they got a message from I think that's you, Wehrman, one of the SIGROC maintainers, that they appreciate having additional traces in the repo. Yeah, maybe. I mean, I started actually adding these traces to the repo for this little FY Gimbal decoder. Oh. Still TBD to actually fix this little button pad. So I do have a Git repository for this project now. So let's look at what's relevant. So actually, there is a repo for the overall Tuco Flyer robot, which is actually, there's an organization on GitHub, github.com/TucoFlyer, and that's where we're starting to collect stuff that that we're all kind of working on together. So this Tuco Chat is a chatbot that Morix is working on, and I'm working on well, lately, this just has a little test script that I've been using to send PPM, kind of pulse width modulation data to the gimbal. But eventually, this is going to be the FPGA and Raspberry Pi stuff related to the actual robot. And then bits for the robot CAD, and then this will be the firmware for the kind of motor controller winchbot pieces. But then specifically for the gimbal, I have this other project. Since I figured just reverse engineering the Gimbal protocol might be useful for various things, I just have this FY Gimbal thing. So that has a little low-level fy poke thing that I've been experimenting with to send commands. I think today what I want to do is make a modified version of this that uses, well, I think first of all I want to run this on the Raspberry Pi, since that's eventually where I'm going to want all this, and at this point I think it might be easier to switch to Linux and use the evdev interface to get the joystick input using the code that I've already written. Tuco's milling about all over down here. What's up, Tuke? So anyway, there's this little command line utility. There's a module that I started writing to decode their packet format. So this is a Python representation for one of their packets, and a receiver that knows how to take a byte stream, or rather a stream of blocks of bytes, and convert that into a stream of packets. A little tester thing. So, and then here's a decoder. I don't know how much sense it makes to put this in tree in libsigrok decoders, because it's pretty incomplete and it's just for one obscure product. But thankfully it's actually pretty easy to use this out of tree now. So the way I do that, so I have this source tree just checked out in tilde source fy gimbal, and then it uses this .local directory for adding your own decoders on top of the stuff that's usually included in libsigrok decode. So here I just added a symlink. So that seems like a pretty easy way of setting this up. And just to bring this back to your comment, Peter, I also have a directory full of traces. So yeah, in fact, I just added the one from our recent internal bus investigation here, this fy gimbal pwm to internalbus.sr. So that one, I traced the PWM signals coming in from my kind of fake model aircraft receiver as I ran the gimbal through its paces. I think I played with the pitch a little bit. I sweeped the yaw all through its range, left and right, and then I held it still and I kind of wiggled the gimbal a bit. So that's the one that's 5 megabytes compressed up here. That's also the one that I've been trying to load into PulseView just to see if it would work, but I think I don't have enough memory on this machine. So this is an 8 gigabyte Mac Mini, and PulseView by itself I think will have already exceeded 8 gigabytes here. Oh, maybe we paged some of it out, but yeah, I think PulseView just does not have the RAM to actually decode this. So this is kind of a visual idea of what we're looking at. Even though this UI is going to be unusable, I can at least use this to point out the features. So these are the bits that we've captured. Yaw, pitch, and mode are the 3 pulse width modulated signals coming in from our PWM controller, which is simulating the model aircraft receiver. RX and TX in this case are the internal buses that go between the first STM32 on the top joint and the second STM32 in this back joint. So I guess the first one is the yaw joint and the second one's the roll joint, the way we have it configured. I can turn this turn this image back on. So yeah, we've been snooping the traffic going from this joint to the back joint, going through some little magnet wires that I broke out in the back for temporaries. Tuco, stop clawing that, please. There we go. So yeah, you can see the little magnet wire harness. Those other 4 wires that I have not connected yet are probably SWD. We still have not investigated to see if we can extract firmware from this device, but that's still on the to-do list. All right. So those are the signals we're capturing, and then we're decoding them in a few different ways. I was using the PWM decoder on these 3 signals, which seemed to work pretty well. And this, I'm actually getting notifications now, so it doesn't seem to give me audio, but I'll get a little pop-up on this machine when someone mentions me in chat. Yeah, I don't know how I feel about, like, the need to watch all the streams, because I mean, I have to do that when I'm doing video editing, and that's a lot of work. I wouldn't necessarily want to wish that on everyone, but yeah, no, if you are trying to watch them in order, then I commend your efforts. There's certainly a lot of video to get through. So we've been decoding these in PWM mode up here, which I'm just using to get some info about what the inputs to the system look like. Ultimately, what I want to do is get some correlation between the PWM inputs and specifically, I think this command 1 message that we're seeing going along this UART bus is probably just kind of a cooked representation of these PWM inputs. But ideally, I wanted to see those side by side, so I wanted to decode these in PWM. I wanted to decode this using the stack of UART plus the FY Gimbal decoder that we've written. So I think I'm going to put the GUI aside and try to do that on the command line again. There was actually a really good hint. Let me try to close this. But let's see. I actually got a really useful comment on the last stream. Are you going to reload the comments? Oh, that's the live stream, which doesn't have comments. This is the one I was looking for. So yeah, MakoMK in chat before suggested that it looks like -s, which is what I was trying to use on stream, went away. But I was looking at some version of SIGROC CLI, and the source code I was seeing seemed to imply that there's only room for one -p option. But then in this comment, MakoMK is suggesting that maybe SIGROC allows multiple -p options. So I think we might try that to see if we can get the command line to decode both the PWM and the UART packets that we're going through. So we can do that using the existing trace that we've captured. Oh yeah, and Piotr mentions that, yeah, sometimes I do recaps on stream, which I try to do more regularly. I know I'm not super consistent about that. The other thing that I want to do once I get back into the swing of having video editing time, so I still have not had as much video editing time as I would like. Previously it was because of day job. Now I'm taking time away from day job to focus on video editing. But now I'm having problems with my displays on that machine. So I'm just taking that as an excuse to work more on CAD/CAM until my parts come in for fixing the display port on that computer. But yeah, once I get more time for video editing, one thing that I do want to do is edit together more just periodic. Because like these stuff like CAD/CAM, you know, I've kind of got this mindset of doing projects where I do all the work on the project, or at least a significant amount of work, like I did with, I mean, I guess Coaster Melt was my closest attempt to doing something as like a serial. And that, I don't even know how I pulled that off in the time frame I did. I think I just wasn't sleeping for weeks at a time. Because each of those Coaster Melt videos was maybe 2 or 3 weeks of research, and then like a week or 2 of filming and editing. And I just wasn't doing anything else. I was just like focusing on that full time because I didn't have a day job at the time, and I wasn't really, I think I just needed an escape from some other stuff that was going on, so I was using that as just kind of an energy sink to just dump all of my energy into. So it was effective but not sustainable. And so I'm looking for a way to do this more sustainably, where I devote some amount of time to filming and streaming and some amount of time to editing. And for stuff like the CAD/CAM, I think I want to do periodic edited videos, which aren't so much like, this is a complete thing, but more like, here's a milestone with some stuff that we've accomplished, and then I can easily point people to the last version of, or the last edited video, or even the series of those small condensed videos. So that's my plan. It isn't quite implemented yet, but I'm pointing myself in that direction, I think. So no more pulse view. Here's our traces. So let's see if we can process this. So SIGROC CLI, input. Oh, I actually really don't like that notification sound. Or the... Sure. FY Gimbal PWM to internal bus. And then I think the next thing we want, that's already going to have our channel layout, but we need to have multiple stacks of protocol decoders that attach to the different channels. So let's just try that first. Let's see if we can do 2 PWM decoders, just since that's pretty simple. So I think what we want is PWM colon data equals, and then it's expecting a pin number. So in this case, the pins, how do we get the pin names easily? I mean, I think I can just dump this out without decoding. Yeah. So this is what we've named them: yaw, pitch, mode, RX, and TX. So let's try PWM colon data equals yaw. Great, so that's just giving us, one of these is the period and one of them is the duty cycle. The duty cycle is actually all we care about, so we can use the annotations -a to tell it that eventually, but right now I'm just going to leave it unfiltered so that we can get a better sense for what we're doing. So let's see if we can specify another PWM decoder now. Looks like it. Well, great. I guess the source code I was reading must have just been misleading me, because this seems to be working as I would expect it, so that's pretty awesome. Now you can see those cycle. I wouldn't necessarily expect them to stay ordered like that, because I think this hardware controller just has a bunch of separate channels, but that's, I guess, how things happen right now. That's interesting, though. Oh, maybe this has to do with the blocks it's decoding things in? Yeah, I don't know why we're not seeing them just interleaved more finely like that. Oh, where's Tuco? Oh, Tuco's sitting under the camera. Okay, so I think that worked. Let's try also decoding the serial. So that would be UART baud rate equals 2 million baud. And then RX and TX are just named the same, but slightly differently. Those actually want to be colons. I find these separators a little bit unintuitive, because to me, colon feels like a heavier separator than a comma. So I feel like these should be backwards, but that's the way they are. Colon separates the arguments to one decoder, and then the comma lets you stack decoders. So this is decoding the serial string, and then decoding the packets with FY Gimbal. So this should just give us a bunch of stuff now. That's probably going to take a long time to decode. And I think the beginning of this has a bunch of PWM before the serial even starts up. So let's redirect this first. Not going to be the speediest. I'm just processing like individual bits in the logic trace in Python. Has it gotten to anything other than PWM yet? It has. So maybe we can pare down the annotations a little bit, because I don't need quite this much. And that might be slowing it down. Oh, Tuco probably wants to go outside. So now I've got to remember the syntax and what all these annotations are called. Do I have the lib decode? Here it is. Let me go let 2 go outside. Back wires. Hey, 2 go, you wanna go outside? Hey, 2, you wanna go outside, buddy? What's your collar? Oh, little guy. He's friends with one of the cats down the hall who is moving out. he and my neighbor that the cat lives with, they're moving, and I think it's kind of sad because I think that cat, Lou, and my cat are friends. Oh, that might be a package. Hello. Hello. Hi, what's up? Oh. I guess that was a delivery. I thought it might have been a pickup. I have a bunch of stuff to send back to Sanrio that is due to pick up today, but I don't know when. This one's from Monoprice. Man, the Monoprice stuff comes with lots of advertising. This is audio cables and ground loop isolators. I had some audio cables in my setup that were not gold plated and were having some really bad connection issues, and so I got some cheap gold plated audio cables from Monoprice. So I'll have to swap those out in my setup later. Always more yaks to shave. So annotations, FY Gimbal. That was called what now? I think I closed my window on that source code. So FY Gimbal, decoders. I think we want all of those annotations. So that would just be -A, FY Gimbal, and then PWM equals some list of annotations we want. So I think this is our chance to tell PWM we don't care about the period. Yeah, duty dash cycle. So let's try that and see if it's doing what we want. Yeah, I think so. So that'll take a little bit of time to crunch, and that'll be interesting. In the meantime, we can get the next part of this experiment set up. So this is the data we're using as kind of a guide for what's going on, but I think we've already got a pretty good idea of what we want to try sending. So these command 1 packets that you just happen to see one of them right here, this is actually what we want to try sending. So my best guess for what these are is some slightly cooked representation of the command coming in over the PWM encoding. And I think from what we've seen so far that these first 3 fields are 3 16-bit numbers. So 1, 2, sorry. Let me actually put this in a text editor so we can play with it. So if we just stick this over here, break this up. So I think that's what we're dealing with. 3 16-bit numbers in little endian. Everything here seems to be using little endian so far. And just some kind of mode byte, which seems to change when we use the trigger to put the controller into a different mode. Oh, Mike says, it'd be cool if you could tell it to only notify you of changes to things like PWM. I'm sure that would be easy to implement, but since this is kind of an analog signal, it's going to be bouncing around a little bit. So you'd have to set kind of a hysteresis threshold. I think this data is going to be useful once it crunches, but this was far too much for, for PulseView to handle in RAM, apparently. So I think the next step is just to get the Raspberry Pi connected to the serial port so that we can start communicating externally again. And we can leave I think it'd be really interesting, actually, to leave the logic analyzer connected to the internal bus as long as we can, so we can take a look at what's actually going on in there. So what we might see is, I think if we're really lucky, what we see is we send one of these command 1s to the first microcontroller, maybe with that target field set to 2, and then we see it send another copy of it with target 1 down the internal bus. I think that would be really cool to see, and that would maybe indicate that the command is working. So, I was also remembering another potential gotcha here, because I was recently having a problem with the Raspberry Pi serial port in the Raspberry Pi 3 being kind of weird. And I think it was because of some changes they had to make to support the serial port that goes to the onboard Bluetooth chip. But luckily, I think this is a Raspberry Pi 2, which shouldn't have that problem. So I think we're just going to wire the serial from this directly up to the pitch and yaw on the gimbal, which is where the serial is supposed to go. I was hoping I had one of those little pinout buggers handy. I don't actually see it. Let's look up the Raspberry Pi pinout. Yeah, this is the Model B. I think the RX and TX are right up here next to that first ground. So this is TX, that's RX. So we can pretty much just stick the servo leads directly on there, I think. So, let's put the anti-static wrist strap back on for good measure. Oh yeah, and Peter is also speculating that it would be nice to have a decoder specific to PPM that translates the servo signals into something nicer. Yeah, that would be nice. That would be a nice project for somebody who wants to learn SIGROC, especially somebody who's into RC aircraft. Just missing a little bit of scroll back, actually, that might have been useful. Anyway, that's still crunching. I am grounded. I will have to change my probing setup again slightly. I also still have my Celia connected to this clumsy USB extender thing. Just something I need to work out. Yeah, as far as active cables, this one I think is the USB 3 active cable from Monoprice, and it actually seems to be one of the better ones that I've tried. They're all a little bit quirky, but this seems fine. Let's stow these mini grabbers. Where did I put that? keep these safe over here. I'm going to see if I can get away with plugging this into my usual USB hub. I don't know that this actually helped with the problems we were trying to work around. Yeah, I can just use this one. And I think everything else can plug into the Raspberry. Spare ground for the analyzer. And I'll leave the red wire channel 2 disconnected, but then channels 1 and 2 are going to be back on monitoring the serial. And I'm again forgetting which of yaw and pitch were TX and RX. I should really write arrows on this board. You know, I think I might have actually saved that implicitly in some of these earlier traces. If I open up one of these traces in Pulse View, I think I can tell which ones transmit and which ones receive. If I have memory to open Pulse View. Well, this is labeled TX and RX, but I think I always kept these in the same order they are on the connector here. So I think that means yaw is TX and pitch is RX. So let's wire it that way. And this would be from the host's point of view, I guess, which is also a little bit confusing. So that means yaw is on this GPIO. The white wire. We can check our work by seeing if we get the power on message from the gimbal. And we might need to do that power on sequence. Because I'm still not totally sure under what conditions it's going to be responding to serial messages versus PWM messages. So I think I might have to implement that power on negotiation that we've seen in the settings tool, where the way the settings tool works is you start it before the gimbal powers on. The gimbal sends out a bunch of messages when it powers on. One of those messages has a version. One of the messages, I think, is saying, hello, I'm here, and then you can respond to that message in a way that interrupts its normal startup procedure. And then you can send it in another command later that tells it to actually start the gimbal motor. So we might have to do that, which would be a little annoying to have to do that as a first step before we even know if this command works. Yeah, so maybe the first thing to do is to keep using the serial adapter instead of the Raspberry Pi. And I was going to jump to the Raspberry Pi next because it would be convenient to get the joystick input, but let's hold off on getting joystick input just yet. I think instead, let's hook the logic analyzer back up to the serial port and then just initialize it using the Windows software, make sure the Windows software is communicating successfully, and then switch the serial port back to this Mac, and then use the Python code to send individual commands. I think that's a more conservative next step to take that'll actually give us better information. So just to make sure I've got this hooked up, I'll plug the logic analyzer back into something. And we can just do a test trace with the Windows software to make sure we're listening properly. Okay, that's plugged in. start that VM. And that's still processing. Let's just use Pulse View to capture this. So the Salier, I want to keep that on Mac. Session. What are all the beach balls for? I can't even quite tell how zoomed out I am a lot of the time in this program. What does zoom 1:1 even mean? Like 1 pixel per clock cycle? Anyway, let's try capturing the channels we're actually using. So 0 and 1 should be serial between the computer and the gimbal. Then 3 and 4 should be between the first gimbal microcontroller and the second gimbal microcontroller. Let's leave that like that. Then 10 megahertz should be enough. Okay, let's try to keep these traces relatively short so we don't run out of memory. Maybe a second. Okay, so that's a buffer of 1 second that we can just run. I think I would like to take a longer trace though for like when the power-up sequence comes in, but I don't know. Let's just see if this is working. I've still got the scope or the power supply floating because the inrush current was causing my USB hub to reset, and this seemed to be a kludge to work around it. So power supply at 12 volts. Gimbal is connected to the serial adapter. We want the settings program to be running here. So we want to make sure that the serial adapter is connected to Windows. Serial port's open. Now I plug in the gimbal. That did not look like it connected successfully because otherwise I would have had a message here. When I run here, I see internal comms, but not the external comms. Oh, I forgot to plug in the fake USB. Which is how that usually communicates. So I have the PPM or /PWM connectors disconnected. They electrically use the same GPIOs as this fake USB serial connector. So I want this plugged back in. The Windows software should still be listening. Yeah. Well, let's just do a large trace, even if this means I'm going to eventually run out of RAM. Oh, nice. So that was the boot up sequence. Here's the Windows software halting the boot sequence. Well, that was actually on 1. A bunch of interesting comms right after that. And then it looks like these are still maybe sensor readings, but we don't have any control coming through. And then if I change settings, you can see it sending that on to maybe the next micro. Let's try, whoops. Let's try save. Go to response. Let's try start. Gimbal's running now. It passes these on. That's seeming pretty nice. Save. Get a response. Okay, let's stop this trace before it gets too big. And that's the door. That might be a pickup. Be right back. Hello. Hi. Yes, a bunch of things actually. Is it big? Yes. Got 4 things. One of them is really big. Cat's not going, but he's sitting on. So there's this one. This is pretty heavy. Cat. Oh, a good hint from Soren that I can use space to run or stop the acquisition. I wasn't having any luck with that for some reason. And I was assuming that when I ran it, it would clear it. I didn't really get any clues as to whether it would or not, so I was afraid to do it while I had anything important in the buffer. But let me experiment with that. Let's save this trace. So this will be FY Gimbal settings app to internal bus. Okay, now that this is saved, yeah, so space does clear it, which is what I was worried about. But I don't see how that helps. I mean, maybe it's a little easier than clicking the super tiny button but I think I was having trouble with it before, maybe due to it not having keyboard focus. Just trying to see what part of this window has to have keyboard focus. I guess maybe just any part. I don't know why it wasn't working before then. But see, that just makes it really, really easy to blow away the capture that you've just taken, which feels a little bit frustrating. So I don't know. That has pluses and minuses, I guess. Anyway, speaking of blowing away the capture, I need to reopen the one that I care about. Is this open? No, this is open. I don't understand why the distinction between stuff that's up here and stuff that's in here. Like, I understand that these are kind of meta actions that apply to multiple of whatever these are supposed to be. I just don't quite understand why certain things are session level and certain things are like application level. Guess it didn't save the directory it was in either. Anyway, setting that to internal bus. This one might be easier to look at with Sigrok CLI, but we could try decoding it here. It just might eat up all the RAM and not actually work. It would just be nice to see the timing, you know? Let's try it. Whoops, that's not what I wanted. Terrible, but yeah. Oh yeah, I mean, have you seen it here recently? I'm live on the internet if you care, but I've been doing electronic streams from this desk over here.
Oh my!
And I just got this rack from all my equipment. Hello, internet. This is my neighbor.
Look at you! You're like a mad scientist. Look at this. What is that?
So this is the rack with the streaming equipment. So all the stuff that's going out on the internet is on this top monitor here, and then the equipment.
It's like a server.
Yeah, it's like multiple servers. Oh. It's like a rack that holds audio, video, and computer stuff.
Oh my God!
And so this is what I'm working on.
Oh, and you're showing people how to do stuff.
Exactly. So I've got like this screen up here is the computer that I'm working on, and then this is the camera that I've been working on for following around Tuco.
Do you record it or they watch live?
Both, actually. So they're watching live, and then I also record things and make edited videos later. Wow. So that's what, like the viewfinder is going out on the internet, but then I also record the card and then edit it together later.
Oh my God. Wow, look at that.
So part of what I wanted to do, actually, since the space has all this vertical room, is I want to have a robot that can just follow around my cat. And so that's what I'm building here. This is the camera. Real? Yeah, seriously. So this is the camera. And so this has... Will it be on a system, or will it be like a fly? It'll be on a system of wires. So like these are the spools. So there will be 4 of these in the corners of the room in little enclosed robot things.
And it knows how to go on the cat, and it just starts.
Yeah, well, it'll actually.
Oh my God, you're gonna get like a million.
Well, Tuco is already a pretty popular cat online, and I think there might be a demand for people being able to follow him around and give him toys online.
That's great. It's like if there's one where you can watch grizzly bears. I watch it.
Oh, that's great. Yeah, there's a cat stream that I like a lot. Kitten Academy. They teach kittens and a cat.
Oh my God. I gotta run. I gotta keep
moving. All right. Thanks for the stories. That'll be super cool. with the video stuff, it's always like having more space to store the stuff. It's always useful.
That's a pretty big one, I think.
Yeah, that's 2 terabytes. That's great.
Oh, no, but that was in the old days. Now that's not as much. But back then, it was
Oh yeah. Well, I mean, I used to have a box that was this high on the ground with 1 gigabyte or 1 terabyte.
Oh, right, yeah, totally. Okay.
All right. See you around. So much human interaction. That was my neighbor who's moving out. He has the cat, Lou, that my cat is really into. They're buddies, and it'll be sad when they can't hang out all the time. Oh yeah, so Soren asks if the kitty runs out the front door. I mean, sometimes he does, but usually it's more like he kind of, demands to go out there, and then I let him out, and then he hangs out, and then he wanders back, and, it's not like he's trying to escape. It's more like that's just part of his domain that he likes to explore sometimes. He doesn't seem... I was worried about him getting, into the actual outdoors. And there were a couple of times when there were some scares where he got lost, and it turns out he was just stuck elsewhere in the building. And so that's why I have a little Bluetooth thing that I put on his collar when he leaves my unit here. This one is 2 megabaud. Oh, I need 4 and 3. And it just starts decoding those as soon as I select anything. That's handy. And a really quick way to eat up RAM. Oh yeah. Well, so I was just laughing at Screamer's comment. Seems nice, but my antisocial self will be saying GTFO. Yeah, I mean, I'm pretty antisocial too, but I like my neighbors here, so I try to temper it a little. Oh, now it's getting very hard to scroll in. Let's see if our RAM usage is getting unsustainable here. It hasn't eaten all the RAM yet. Maybe this will work. Maybe this extremely smaller trace will actually work. It's just all these, what I assume are IMU update packets are kind of clogging it up. But it seems to be decoding things just fine. It's really tempting to jump ship and do this on the command line, since I wouldn't have Beach Ball City, but I am kind of interested in the timing here. Speaking of command line, that thing finally finished. Oops. Oh yeah, that was the PUWM to internal bus. That was not our new one. Given how long it takes to decode, it's really tempting to check this in also. Ooh. That was... So I think 1 and 2 are going to be yaw and pitch, and 3 is going to be mode. But what is that? Oh, I think that's during startup where it's sending out serial packets. And so I have some malformed PWM stuff around there because it's like serial data clashing with my PWM outputs. So that's fine. That's just going to do that for a bit. And then we actually have the initialization. So the D packets start flowing. Those are the ones that I think are IMU updates, but they don't have any content yet. And then 1 are the actual commands, as far as I can tell. That's kind of interesting, but I think we'll need additional tooling maybe to actually make that correlation between, or maybe just some well-placed greps. I'm actually more interested in this thing that's currently loaded into PulseView because that'll tell us how the commands flow from micro to micro. If this will ever load. I might just jump to the command line over here. Okay, command line time. This is not usable. Hey, Tuco. Are you hanging out over here now? Meow. Robert is asking, did the decoded packets contain floats, or where are those percents from? That's the measurement of the PWM duty cycle. This is from the PWM decoder. What's going on, Tuco? Okay, so let's do a similar command line based decoding, but instead of a bunch of PWMs and this FY Gimbal chain, we're going to have 2 of those FY Gimbal chains. Tuco? Hey, Tuco, do you want to play? Can I take off your collar, boy? Hey, Tuke. Now I'm just keeping my eye out for a bolt. I think that's what he wants. Tuco, where is your toy? Do you just want attention? Are you looking for a toy now? I don't understand him right now. Let's remind ourselves what the names are here. Oh, these channels are not named, which is a little bit annoying. I probably should have named them before saving this. I guess I didn't really know which directions would be relevant at the time. Let's try this. UART. So that's the first. Oh, and FY Gimbal. And here's the second. Oh, that's right, I skipped channel 2. It was 0, 1, then 3 and 4. 2 is the mode in my other setup. This is better. Let's put this in a file and let it run. So here's what we're seeing so far. Here's all the IMU packets. Well, what I'm assuming are IMU. Oh, these came in really fast. Let's maybe switch to just running, or just opening up the results in less. So I'm just looking at the startup here. I think I maybe got this RX and TX backwards. This is the stuff the gimbal spurts out as it's starting up. Anyway, the RX and TX don't necessarily matter that much. So this is the gimbal spitting out its I'm here message. This 7.3 is the firmware version. So this is probably something else, and then the firmware version is a 16-bit number, maybe. They might have made it an 8-bit version, but then they can only have versions up to 2.55 the way it's encoded. So it's probably 16-bit. And then this is the packet that the Windows setting software actually responds to. So if we want to interrupt the Gimbal's normal startup and put it into serial port mode, I think this is the exchange we'll need to replicate. It's interesting that it sends out another burst of these right afterwards. That's Command B, but a different target this time. Oh, this is the internal bus. Okay, great, right. FY Gimbal 2. So this is the command sequence that the Windows software is responsible for. The Gimbal says, I'm here. The Windows software says, hey, I'm here too. Stop doing your normal thing and let's talk. And then right after that, it looks like we have this sequence between... This looks like the first microcontroller telling the next one, hey, go into this mode. And then this is our IMU packet stream starting up. Okay, so then where's the next time we talk to it from the Windows software? Was that the startup? Command 9 and then Command 6. That doesn't tell us a whole lot yet. I think Command 8 is the one that kind of reinitializes some part of the control loop and also specifies the heading follow speed. What I was looking for was the command from the Windows software getting passed on somehow. Looks like it does, just after a bit of a delay. That's the Command 8. That was the Command 8. Can we find something simpler? Well, maybe Command 8 is a good place to start with. This is the heading speed, I think. So this is the first place we see it. This is actually the Windows software transmitting it to the Gimbal. I'm going to swap the first RX and TX because that's really confusing. Oh, SIGROC segfaulted. That's handy. Is it going to do that again? Okay, so now RX is stuff we're receiving from the Gimbal. Now this is from the computer's point of view, which is how I've been trying to orient this. I haven't gotten to the point of decoding any Command 8s yet. So one thing we can do while we're waiting on stuff to decode is just go ahead and send it some commands and see how it responds. I was hoping to get an idea of what the targets actually meant by reading this trace, though. Also notice we're not getting any command 1s here, which is a good sign, since my theory before was that command 1 was being internally generated from the PWM data, and it looks like we've disabled that by having the settings app do its handshaking, and now maybe we can send our own command 1s to command the gimbal. Oh, also, I should reset the gimbal because it's doing the thing where I had this problem before where I left it kind of pushing itself against the end stop for a while, and then the motor overheated after a while. So I'm going to try to avoid doing that. I think what I actually want to do is start up the gimbal, but have it be off, which I can do with the FY gimbal setting app open. So is this still connected? It should be. Connect success. Okay. So this should be back in that mode where you can see it's limp, but it's still talking over the serial port. And I can power it on from here right before I run my experiment. Yeah, let's let that crunch a bit. So the packet we actually want to try sending, that'll be something like what we have in here, PWM to internal bus.txt. And we're just looking for these command 1s. So here's an example. It starts out in mode 1, which I think is this last byte, and then we're sending some stuff that's all pretty close to 0. And we see it sent to target t equals 1 at this point, but I want to see if we can get this, I want to see if we can reproduce this showing up on the internal bus by sending this same command to the first microcontroller, possibly with a different target number. So that's an experiment I think we can do right now. Oh, this crashed again. Am I going to have to debug this? Do I have LLDB? What was that? I think that was me not using LLDB correctly. I'm still not really used to LLDB. I'm so used to GDB instead. Oh man, this is going to be really annoying to debug. Oh. Yeah, that would be true. Where is that coming from? Okay, let's see if that crashes somewhere useful, and in the meantime, let's look at the data we have. So command 08 comes in from the Windows software. Then I guess that first one didn't go anywhere. But then, oh, interesting. So here's one from the Windows software with t equals 0. And that doesn't seem to go anywhere. Here's one with t equals 1. And then you see a t equals 1 come out. Here's the Windows software sending a t equals 0 and a t equals 1 again. And then only the t equals 1 comes out. So yeah, maybe 0 is... I'd been assuming that 2 was the first micro, but maybe 0 was the first micro. This definitely seems to be just passing on the command with a different t number, though, or with the same t number, I guess. In fact, here's two command 8s right after each other. There's a 6, 7, whatever, and then the 0, 0, or 0, 8, 0, 0. Those are both T2. Then here we have that first one passing through with T2. But then I don't see the second one. Oh, there it is. Yeah, so that does seem to be just like the software forwarding it from one serial port to the next through some buffering. Well, let's just try this with some commands we're making up. So let's start the gimbal. The gimbal is alive now. Let's start it again on camera. I don't know why it's pointing that direction. Unless somehow I assembled it with the sensor tilted a little bit or something. Or maybe I got some offset stored in the settings. Oh yeah, Robert is asking if SWD has been investigated yet. I have not looked at the SWD yet. That's still to be done. Alright, so that seems fine. Let's just disconnect that from Windows. So now I have fypoke, which will take a while to load. Or maybe not. Oh, that's right, it was just waiting. So, right, it sends one command and then waits for responses. Which might not be the best way to do this, but let's see. So, I think the default port is fine. Default framing. Command 1, target. Let's try 2. I think that's what we want. And then command, let's try just some zeros. So that's 3 16-bit zeros. Actually, these all get joined together. I can have arbitrary white space, so let's do it this way. So that was supposed to be the command we sent out. You know, it'd be nice to send something that we know we'll get a response to in order to test this communication. Ooh. Double free, maybe? In Sigrok? Let's just decode this one to a text file also, because I kind of think that would be handy. This one is a shorter trace, yeah. Okay, so this should have some interesting bits for us. Oh, this one's also labeled from the microcontroller's point of view. So TX data is the microcontroller, bootloader messagey thing. Oh no, maybe I'm wrong. I think this one starts after that. I always assume these traces start from the beginning, but I think this one was already connected. And then I restarted it right here, I think. This command has a response. So command B was the thing that we were responding to on the computer end, I think, and then command 9 has a response the other direction. Let's see if we can replicate this. Let's save that for later. Oh, target needs to be 3. That doesn't appear to match what we have. But maybe we're just not using that command right. Command 6 also seems to have a reply. That looked like it worked. So we sent this command 6. This might have been like one of the save commands, and it responded. Okay, so we are talking. So I want to go back to sending command 1. Let's try all the targets we know about. But first, let's make a command that seems like it would be likely to do something. So we have these 3 numbers and a mode. I think the first number is yaw. Let's try setting this to something smallish and positive. So that's like 300. I think actually what we want to do is be looking at the internal traffic as we send these, because I think that's going to be easier to see if we're doing something right rather than trying to just watch the gimbal move. So sending zeros and then watching the commands go through might be nice. Can we do that in real time? I think we realized, or I think we determined we probably couldn't. Yeah, so maybe we capture a trace, send them into commands, then look at what happened. Okay, that's actually configured mostly right. Let's set that to 10 meg. Set this to be big. Oh, is that a decoder? Or is that the ruler not drawing? Okay. This I want to delete. Hey Tuco, you found a bolt. Where'd it go, little guy? Where is it, Tuke? Here it is. You're so into that, Tuco. Is it recording? Oh, there we go. Yeah, I guess it can be zoomed out really, really far, and then I just don't even know if I'm recording. And so I can start and stop, but it overwrites it every time, which is a little worrying. I don't want to debug this right now. Oh, maybe this was just crashing on exit then. Maybe I got all the decoding? Oh, that's fine then. I mean, if I was developing SIGROC, I would really want to clean this up, but as a user right at this moment, I don't know that this affects me. Okay, so I've got this command 1. I'm going to try... So I don't want these to be large numbers because I don't want to be breaking the gimbal by sending it commands that cause it to move really quickly. But I do want to give it something that I can see move through the pipeline. So maybe just a little number in each of these. Let's try this. 5, 6 was starting to get large enough to worry me. All right. So I'm going to start the trace, then send these with target 0, 1, 2, and 3, and then we'll record what happens. Let's give these better names, maybe. So we don't need that one anymore. Internal, maybe. Hey, Tuco. There's a 0. There's a 1, and it passed something through. A 2, and I got a response. Oh no, I didn't get a response. That was just the packet going out. Okay, so I sent 0, 1, 2, and 3, which are the target codes I've seen so far. And it looks like it passed that along in everything except 0. So, it's tempting to try other target codes also. Let me do that again, but also try 4. And maybe I'm going to modify fypoke really quickly to not read at all. I should probably add a command line option for that. Does this work? I'm hoping it actually flushes the buffer, but I guess I'll see. So target 0, 1. I could really just write code to do this, but I'm just doing it once. Just incrementing this. Huh. That looks like they're masking off bits. But anyway, let's save this and then decode it. This will be FY Gimbal command 01 propagation test. I like Robert's comment about getting a box from Amazon that you can turn into a functional recycle bin just by turning it inside out. Okay, let's do this again. Sigrok CLI, then FY Gimbal command propagation test. Oops, UART. Let's test that. Looks like it's decoding what we want. And let's save that into a text file so we can analyze it more easily. Hey Tuco, do you have a toy for me to throw for you? You totally do. I love the little chirpy noises he makes. Sometimes it's like he's saying thank you or something, or like, oh man, I really want that. I think I just want to let this process and then grep it for command 1. Hey Duke, where'd it go, little guy? I heard it right down here. Tuco. He's so good at putting the bolts in place that I totally can't find them. Tuco, I don't see it. Oh, there it is. Whoa. Didn't want to go after that one, Tuke? He's like under this table. Okay, well, I'm going to assume that's maybe the same problem. I wonder if that's something that occurs when you're using multiple decoder stacks or something. All right, there's our goodies from this test. So FY Gimbal 1 is the communication between our Python script and the first processor, and then FY Gimbal 2 is between the next two. So the 1s went through, the 2s went through, the 3s went through, and then the pattern starts over again with 4. So it could just be comparing the lower 2 bits and saying, you know, if this is 0, it's for me, otherwise pass it on. T might also indicate who to pass it on to rather than, because I mean, if the microcontroller is getting it, it always has the opportunity to respond or to process it, but it's possible this indicates who else wants the message. But if they have the facility to broadcast one message to a bunch of microcontrollers, I don't know why they would be sending the same command multiple times with t equals like 0, 1, 2 when they're doing initialization. Next project after this, auto bolt scavenger made from a Roomba. That would be useful. I think the bolts end up in places where it would be difficult for a robot to get to them. But that would be one use for a quadcopter maybe, because it's basically a little air compressor. So it looks like the packet contents also got passed through, which is nice. I wonder how long a buffer it has for storing these packets before it forwards them. Anyway, so it'd be kind of nice to see what the communications are between the other micros, but I think maybe at this point it would be useful to just start putting maybe different values in here, or even a joystick. So the gimbal is still kind of drifting that way. Let me see if I can just aim it with this command line tool. So we probably want target set to, I'm going to guess 3 in case that's a bit field. It might also just be a microcontroller number. And then let's start with these at 0. And then I'm just going to send, so this is yaw. Let's try sending it something not too big. Don't see anything. Maybe that's not used in the current mode. Let's try the next one. That's probably not useful. This would also be a little easier to check out if we had the camera on screen, so we could see even small motions. Let's try changing the mode. The only reason I'm not connecting this to a joystick right away is, well, mostly I have the joystick driver set up on Linux, but not on Mac OS. And the intermediate step we have to go through before getting this to work on the Raspberry Pi is, right now I'm using this trick where I set up the gimbal using the Windows program and then swap it over. And to avoid having to do that, we would have to just do that initialization handshake in Python also. Which is not hard, it's just something that I don't want to have to go through until I know this is going to work. It does seem like the gimbal is drifting in that direction. It hasn't quite hit the end stop yet. There's also my theory that it might not respond to these commands unless they're coming in frequently. Like there might be some kind of watchdog. I'm not seeing any movement out of this so far. I'm pretty sure the micro wouldn't be responding to serial commands when it's in the mode where it's also responding or receiving PWM commands. I would expect those to be mutually exclusive. Yeah, so where to go next? Is this a 32-bit number? I'm just looking at Command D, which is not apropos of anything, but this makes a lot more sense if the first 4 bytes are a little endian 32-bit number, assigned 32-bit number. But if that's like some kind of IMU data or something like that, it would be interesting for that to just be one number without any context. Unless, I guess my other theory is that there would have been additional messages like this that would have just gotten eaten up by the time we've reached the root joint of the gimbal. The gimbal is definitely drifting in that direction slowly. Don't know if that's due to something I've done or not. What do you want, Tuco? Well, given that I'm a little bit out of ideas, maybe this is a good time to wrap up the stream for now. I could take a walk and get some lunch and think about it, and if I come up with something, I'll be streaming whatever comes out. Do another stream this afternoon. So what do we have so far? So this stream, just from a higher level view, this is about trying to get this gimbal to work with, well, there are a lot of ways to get this gimbal to work with the Tuco Flyer. This particularly has been to try to reverse engineer something which we're assuming exists but haven't actually seen, which is that it would make sense for them to have a serial command you can send to position the gimbal rather than using the pulse width modulation signals like you'd see in an RC aircraft kind of thing. Besides being more convenient, that also, I hope, would let us specify an absolute yaw angle instead of just a speed, which helps a lot for how I want to use this. Without that feature, I think we can only specify a speed using PWM inputs. So to kind of convert that back into a position by building our own little feedback loop, we would need to know where this is pointed. So my solution for that was going to be to try to tap the signal out of the magnetic encoder on the top to get a sense of where this joint is actually angled. But when I was about to start doing that, then this other idea came up, which was, maybe we should just reverse engineer the serial protocol and see if it has a way to send the position that way. So we still haven't really gotten to the point of proving that this command even exists, but we know a lot more about the serial protocol, and in particular, we're starting to find out more about how the different microcontrollers in the gimbal talk to each other. And it is looking like there's some kind of daisy chain scheme where each microcontroller picks the messages that it's interested in, and then also forwards messages on behalf of the other microcontrollers using some rules that are determined by this T byte. Which, this is really just the first byte in the packet after the framing, which I've been calling the target identifier. But I don't actually know whether it's just an ordinal number or a bit field or what at this point. We've seen values like 0, 1, 2, and 3. It does seem like it could be a bit field. What do I get if I send these to target 3? I've been trying that, right? This gimbal, because it's drifting, is also getting kind of close to its end stop, which I'm a little concerned about. I'm just not seeing anything here. I wonder if there's something about when we're turning on the gimbal, we have to tell it where it gets input from. And maybe it defaults to PWM mode, but maybe when we're issuing these start and stop commands here, so like this isn't actually going to work because I have the gimbal disconnected from the VM. But if I connect the gimbal back to the VM, Tuco's inspecting my cardboard pile over there. This program really wants to see the gimbal boot up. I should really just replicate this in Python. It's getting annoying to use this Windows program. So maybe one of the next things that I do is to get this handshake where I connect to the gimbal and report the version and turn it on and off myself to get that part working. So here, I can click start, and then the gimbal powers on. And now it's just pointing a completely random place. Like, why was it pointing over there? Did I somehow put the gimbal into, like, infinitely slow heading following? I think it just doesn't know where the front is. No, that looks like infinitely slow heading following. I guess I disabled heading follow somehow. How did I do that? You know, this probably changes depending on the mode that I send over PWM. I don't really have the PWM set up right now. I could plug the PWM back in, but I don't think I care. I think the thing I want to do is to better understand the gimbal start sequence, because there are a bunch of unknown values in there. I suspect if we started figuring out what those actually meant, we might find something that enables these commands the way we want. Since we are making some progress here, we know we can send these commands. I think I know what the format is of the commands. I don't know exactly what the numbers are, but I know how to send something that is probably parsable. But it seems like that might just not be enabled. I'm going to check in these text traces because they're a little bit slow to compute and the files actually aren't very big. Oh, whoops. I didn't have that set for some reason. I thought I set these are on this machine already. Well, I didn't... Tuco, what are you doing over there? Oh, he's hanging out on the chair. That's really cute. Not anymore. All right. All right. So that should be fine. Oh, I think I set that on the Raspberry Pi, but not here. The author info. Okay. Well, I think that's about a good wrap-up point for this little stream. I know this hasn't been a very long one, but this one at least, I feel like I could try a self-contained thing. I'm already finding myself thinking about the plan for what to do next and whether I should just do that right away. So I want to get the gimbal connected to the Raspberry Pi. I want to have something in Python do the initial handshake so that we can start sending stuff to it. And then that same program can probably also read the joystick and send these packets to it. So we'll be doing that on the Tuco Flyer. FY poke, FY proto. Let's at least mount this so we can edit this locally. Do I still have it mounted? Had something completely different mounted there. Hey, Duke. What's up, little dude? Okay, so I'm starting with the simple kind of poke program that I wrote to just first write a command and then read anything that's available. Since we're on the Raspberry Pi now... Hey, boy. Since we're on the Raspberry Pi now, and it's Raspberry Pi 2 and not Raspberry Pi 3, I think we have TTY-ACM0 again, or AMA0. Let's make sure we've got the serial port all to ourselves. What? I think that doesn't actually mean the entire serial port is disabled, even though the message is kind of misleading. Yeah, so can I do that without rebooting? No. Who is starting that? Okay, fine. I'll have to reconnect my SSHFS. Oh wow, just catching up in chat and reading Chris's message about KiCad having its own coroutine code that doesn't save FPU registers. Man, I have written code like that before that would probably, yeah. I had this thing that I wrote at VMware which would catch, it was like a It's like a terrible, terrible crash handler. 'Cause we were having these bugs in OpenGL that we still wanted to be able to gracefully recover from. Like you're running some graphics intensive thing in a VM, it partially crashes your OpenGL driver, but we want you to still be able to like save your work a little bit and kind of keep your VM going. So it's basically a segfault handler that unwinds the stack and tries to get the libgl back in a functioning state. It was pretty bad. Around. TTY, ask me anything. Did that really turn off the entire port? Really? I hear you. Maybe the message was real. Maybe it was actually turning off the entire port. Why? To go. No, but I want you to turn the serial back on. How does this work? What? That's not what I wanted either. Go away. This cat. Enable UART. I know. Yeah. So I want the UART to be enabled, but I don't want this in a init tab. So let's do these separately. So this is editing a init tab and setting console equals blah. So maybe let's just tell Raspberry config to turn off the serial and then actually edit the boot flag to turn the UART back on. That's really not what I wanted. Oh yeah, that's right. I wanted that to be off. So login shell off. No reboot. Oh right, system. Oh, we're using systemd here, really? Oh, Tuco just wants everything. Tuco, I know you're looking for a bolt, honey. Didn't we just have a bunch of bolts? Systemd. So how does this do that in systemd? I guess it does that with this device tree alias to set up a console. Okay, well I'm just going to trust Raspberry config did that right, and I'm going to edit the boot command line. but this is not what I remember either. So we've got console equals tty1, Plymouth.ignore serial consoles. This might just be something different about the different Raspberry Pi models. Oh, that's something about the splash screen. Okay, that doesn't have anything to do with... Why am I not seeing that UART option in the config then? Set config var. What does this get set in? Ah, that's the... Right. This is a very Raspberry Pi thing. Okay, I think now we'll have the UART all to ourselves when this boots up again. Oh, apparently my Raspberry Pi config is old. Interesting. I thought this was a brand new install, but it's possible I didn't update it. Oh, that's a pretty toasty looking SO8 up there. Oops. Oops, I did not want to click Spotify. Go away. Let's have the updates go. All right, we got our TTY Ask Me Anything. So I think the first thing we want to do is just listen for all incoming packets, print them out, and then if we see the packet that we need to respond to in order to halt boot up, we send it. Stuco, want to go outside again? So I'm just going to look at the settings app to remind myself what that actual command sequence is. This is the settings example, text decode. So this is the Gimbal booting. I think the way this trace worked is I kind of put the app through its paces, starting from with everything already running, and then at the end I reset the gimbal to get a trace of that. So that's what these are. It starts out with the spam of AA55 framed messages with the firmware version. So let's maybe decode that so we can at least print that out. Tuco really wants to go outside. Tuco, you want to go back out? Go back outside too. Go around. I was going to try to keep track of if I've already received this version packet, but I'm not going to bother yet. So something like that. And then, so those are just being printed out for informational purposes. And then this is the one we're actually responding to. Oh, maybe t equals 3 is something the PC software is supposed to be responding to. So now we're looking for a 5A5 command B. Data, just a byte array. Yeah, data is just bytes. And I could be using that short form and long form. But it's easier to just call out what the framing is at this point. And that just sends an 01. So that might be something we need to change. Like this might be like a interaction mode or something. But it also might just be saying, hello, I'm actually here. And we're sending these right away, these command 9s. These might be asking for something. So it looks like command 9 is asking for some result here. Same with command 6. And then I think this is actually what starts up the gimbal. So these I think are just like on-off commands. So it sends off to all the micros, then on to all the micros. And then this is the same command we saw before with like a horizontal speed, but I think this might do different things depending on what the first word is. This might be some kind of parameter space, like maybe this is like parameter number 67 is 01, parameter number 8 is this. And if that's the case, I hope there's a way to read from that same space. probably isn't that. So responding to the init packet, that would just be B and O1. I think that's all we need to do, but let's go ahead and send these other inquiries. So this is a 9 to target 2. And the B, I should put the target in that one explicitly also. That was to target 0. So target 2, command 9, and just a single byte. Is that actually how you get a 1-byte array? Yeah. And then 6.5 to target 0. And 6, target 0. So the other thing I'd like to do is actually power on the gimbal, but let's make sure this works first. So if this works out, then I should be able to run this and then plug in the gimbal, and I should get some of these packets with responses, and the gimbal should not actually power on yet. So FY remote. Oh. Do I have Python 3 on here? I do. Oh. Right. PyCRC is useful also, but this needs a different CRC module. Hey Tuco, what's going on, buddy? Okay, that might be waiting. So let's try resetting the gimbal, which has again reached its end stop, so I should give it a break from that too. Heat sinks are getting a little warm already. Oh, right. It is not connected to the Raspberry Pi, it's connected to the Windows software, so we have to... It was doing what we wanted, but because the Windows software answered. Tuco, what do you want? Okay. Oh man, Tuco. Probably going to get TX and RX backwards the first time I do this. So unplugging the tiny fake USB again, which is actually the serial. And then on the Raspberry Pi, the RX and TX are just to the left of this, or just to the right of this brown wire. So we have TXD and then RXD. I think the order we want is yaw, or the white wire here, and then pitch, or the blue wire on RXD, but that might be totally backwards. I also don't have those connected to the logic analyzer quite yet, but we probably want that eventually. Let's just try powering on the gimbal and see if we get to catch that. Alright, FY remote is just hanging out. Alright, gimbal on, and if this doesn't work, we swap the serial wires. Oh. Ooh, tabs. Let's fix that. That's better. How did that buffer get set to tabs? Let's fix our bug. Oh. All of this was missing an indent. Ooh, tabs. Let's fix that. That's better. How did that buffer get set to tabs? Ooh, this buffer's in tabs mode also. Let's try that again. Can we get this gimbal to start up without starting up? If this works correctly, the gimbal doesn't move. Nope. Oops, that was the wrong file. Let's put it in the right file. Struct. Again. Jesus. What just happened? I guess it doesn't like if I respond to all of those packets. Guess we got into a loop. So we get to the point of responding and sending other stuff. Then we get a response to this. Oh, we get another response to this init packet. I don't know what caused that. Let's try just sending less stuff and only sending it once. So let's not do any of this yet. Oops. Oh, I hope I don't break this gimbal trying to reverse it. That would be sad. Don't know why it did that. I think this will be harmless, but let's find out. Alright. Powering it up. Brrr. I don't know if I sent this with the right data contents. Was that the problem? Yeah, this is supposed to be a Command B, target 0 with a 1 byte. Command B, target 0 with a 0 byte is not what I wanted. I think this was supposed to be that. I think we got 1 byte instead of a byte that was 1. Let's try that again. Maybe I'll try to hold the gimbal to keep it from spamming itself up against the sides. Was that the please destroy my gimbal flag that I have to turn off? Okay, I think that was it. I think that was it. I think I just had to have a 1 there instead of a 0. Apparently 0 does something unhappy to the gimbal. Let's try these. I think these are just regular inquiries. I don't think they are going to do much. Run that. Gimbal's still off. Okay. I think we're now in a mode where we can start building on this with something better. This is also not what I wanted. Yeah, those all needed to change. Great, so now I can just power cycle the gimbal without it mechanically doing anything. And I get that stuff. My questions seem to queue up. Oh, that's interesting. The response to 6 came back before the response to 9. Like maybe this is just asking something out of local memory and then... I wonder if this is the same space that we've been seeing in 8. Like if we send command 6s with a bunch of different keys here, will we get a bunch of different values? Is that a way we can dump its settings? Let's try that. I feel like I'm probably going to overflow some buffer unless I send these slowly. Maybe let's just send them in order every time I get a response. So that was a command 6 response. I should probably just make those framing bytes part of the command number somehow. So I'm just going to try looping through all these to see if we can get some space of configuration commands out of the gimbal. My hunch that I'm trying to follow is that maybe this command 6 is returning something from a local configuration space, and like in RAM, and that this is just an index into a table, and that this is a 16-bit number from that table. And my extra hunch is that maybe that's related to the table that we're setting with command 8. So fy remote, and I just want to run through these. So command 6 counter, every time we get a response, which will start with the 6.5, we're just going to send another packet. So we'll see if that just sets up a loop where we end up just sending these repeatedly, but hopefully not overwhelming anybody's buffer. Let's try that again. That looked good. Okay, this was the other command responding after a delay. But yeah, it looks like we've got a space of 16-bit numbers. So is this related to the, because it definitely sends a couple of command 8s when we're starting up the gimbal down here. So my hunch is that these are related to the numbers in that table at entries 67 and 8. And that this is then, this is probably a table entry, some other byte that might be reserved, and then the actual 16-bit number. This might just be a padding byte, or it might be used for something else. But yeah, we're setting 67 and 8. We're reading what looks like 65. I don't know why it's reading this. That's interesting. What is 65? That's the same value we got before. It's next to some other stuff in a similar range, so these might be speeds. There's probably a whole bunch of juicy stuff we can set. This might also explain why the gimbal has been drifting lately. Like I might have accidentally clobbered one of these values. So I'll probably have to build some kind of tool for kind of editing this table of values conveniently. But at least I think now we know what that's for. We start building maybe a little bit of documentation. So long form commands. Command 0 is firmware version. I'm going to bother describing these in too much detail right now since we've got the traces for that. But at least having, I don't know, having this organized a little better. I think that's where we're at so far. So 3 might just be an on-off then, if 8 is like setting variables. What is this? So we've got 8 for 67 and 8 for 8. So 8 is 0 right there. '67 also starts out as 0. This just sets 67 to 1. I wonder if that's like a run mode. and O3 can be on-off. Let's turn off this enumeration thing for now. Let's try just turning on the gimbal. Let's send this sequence of commands. So targets going from 2, 1, 0, and then we're sending them all 0 and then 1. So I think this is just making sure they're all off and then turning them on in order. And 3. Why do I have all this stuff at the end of the line? Okay, so this is going to turn them all off, then turn them all on. Let's try that. So right now the gimbal's off. I'm going to unplug it, and then we should, what I'm expecting to see, well, actually it's already unplugged. Okay, it's very off. So I'm going to plug it in. What I expect to see is the handshake where it says what version it is, then we respond to that, and then we will tell it specifically to turn on, which should have it on but still responding to serial commands. Huh. It moved a little bit, but let me also take out that thing where I'm preventing repeated commands, because that's not really an issue in practice. And then I won't have to worry about restarting this program each time. So if you look at the gimbal, see, it twitches a little, but it's still limp, which is different from last time. I think now we're actually in a pretty safe state for experimenting with those parameters, though. So now the gimbal is up. I think we've just turned on the joints. They just don't, like, they might have their actual motor drive strength set to 0 or something like that. So what I'm guessing is it's in a state now where we can start sending commands to those, like, into that parameter space, the one that you access using the 8 and which commands? The 8 was for setting those, and I think 3. Oh yeah, so 6 was the getter. So yeah, I think it'd be really nice to just have a program where I can go through this command space and edit all the values. And that might even be enough. Like, I suspect there's enough in there that you could probably find a way to aim the gimbal just by editing these. But I think we're also pretty well positioned to try out command 1 once we know that the gimbal is trying to hold a position. I think maybe I've corrupted some of the settings in there. So, like, for example, when the gimbal was operating normally, it was pointing in a really weird direction and wasn't responding to heading updates. So, like, I think I might need to understand some of those settings in order to just fix whatever I've accidentally corrupted. But yeah, I think that might be a good wrap-up point for this stream. So we've got kind of a nice space of parameters for this gimbal to fuss through. We kind of know which direction to go in here. I think really the next thing to the next kind of hurdle to get through is just figuring out how to structure this program to most effectively test out the different gimbal commands. I'm thinking that a combination of some little command line REPL that I can use to poke at these config values, plus just a way of gluing axes on my joystick to fields in that command 1. I think that's what I want right now. And this is going to turn into kind of a shell of a program that might eventually be able to drive this gimbal using the joystick, and then might turn into a library for driving the gimbal, which is what TucoFlyer is going to want. This does mean, at least unless I can find a way of activating the serial port after the gimbal starts up, it might mean that I need a way of having power control for the gimbal from software. So I'd be able to actually turn on this micro after I know that I'm able to respond. I don't know if I have a way of getting the micro's attention otherwise. That might be something we have to keep looking for. Is Tuco inside? I kind of wanted to take a walk and get a sandwich, maybe. Looks like he's hanging out on the rack, actually. There's the little fuzz muffin. So yeah, let's check in this code that we've got so far. I think my plan for after lunch is going to be just going back to this, but writing kind of, I think like I was saying, like I think a joystick input and some kind of REPL that I can bolt onto this FY remote thing. And that might just be using the Python REPL and making some functions that I can call with it to send either changes using command 8 or to send GET requests. Or maybe I just get everything at startup and keep track of them locally. This might even be, like this is one of those things that having just a window where I can just edit these all would be kind of handy. But I kind of want to keep it all command line if I can so that it's easy to run on TucoFlyer. But anyway, let's check this in just so we don't lose anything. Oh, right, that's the wrong computer. Let's maybe, before we go, add an option for FY poke, because I was just going to clean up my tree, and I have that in tree change right now. See if I remember. I can almost never add anything to argparse without consulting the documentation. I think this is how you do it. Oh, parset. Made the Kessel run in less than 12 parsets. And just so that this is a little bit less crazy, I don't know, let's just make this something generic. TTY USB 0. Cool, so that does nothing unless you send it a command, in which case it would do that, or you could do read, in which case it'll sit there trying to read, which is what we want. Right, passwords. In case anyone is curious, I am sure to use passwords that don't matter when I'm on the stream, but I appreciate the concern some of you have when I type the passwords on camera. I have separate passwords for the streaming machines and the non-streaming machines, of course. Okay, I think I've got what I wanted. So, we'll have a little intermission. I'll get a bite to eat, and then I think we'll go back to working on this, will it show up in here? Yes, this FY remote tool. So right now, all it knows how to do is respond to the kind of initialization handshake that we've seen the Windows tool responding to. But it looks like we've discovered some things that are really interesting to poke at. So this command 6 combined with command 8 are getters and setters for a 16-bit ID space with a bunch of parameters in it, which should be super useful. And we've also got command 1, which seems to have just incoming kind of angles or speeds or something. And so that will be interesting to hook up to a joystick. So, I think that's it for this morning's stream. Looks like Tuco's napping. I'll let Tuco nap while I walk to the sandwich place and get myself something to eat. Happy hacking, everyone. I'll see you next time. I'll be streaming again later today if you're around, but as always, see you on the internet, and this stuff will eventually make its way into video blogs on scanlime.org once I have a little bit more of the right time and equipment for editing, which I've been slowly putting back into place. I think now I've got the time finally, and I'm just having some small computer problems, but I've been using that as an excuse to make some more progress on the Tuco bot. So, we'll see you all next time.